9.6 Graph quadratic functions using properties. So in this section, we're gonna look at a lot of informations about quadratic uh, functions. Okay, so first, in chapter 3, we graph quadratic functions by plotting methods, which means that we find the solutions randomly and then try to get the shape of the parabola. Now we can graph a lot faster by these property. So quadratic functions, okay, is basically written in this format. F of x is equal to ax squared plus bx is equal to plus c. And then a, b, c's are real number, and then your a cannot be a negative number. So in quadratic functions, first thing what we want to do is we want to find out the vertex, because the vertex is the tip of the graph. So, and then also it is in the middle. So that way it make it easier for us to graph it. So how do we find the vertex? Here's the formula. The x-coordinate of the vertex will be denoted with h, and then the formula that helps you to get that value is minus b over 2a. And a, b's are coming from this quadratic functions. If you know the x-coordinate, all you have to do is plug it in x-coordinate into the functions to get your y-coordinate. So therefore, the y-coordinate denoted by k is basically you plug it in the x-coordinate into the functions right here. See, f of minus b over 2a. And that will give you an order pair hk, which is the vertex. And the axis of symmetry, since parabolas are symmetrical, your axis of symmetry will be always a vertical line that passes through the x-coordinate of the vertex. So therefore, it will be x equal to h, which is the x-coordinate of the vertex that we have. And the parabola can be opening upward or downwards by looking at your leading coefficients, your a value. If the value a is greater than 0, then the parabola will be opening upward. And then if the value a is less than 0, then the parabola will be opening downwards. Okay. So what is the other property that we want to look at into it? If the parabola is opening upward, your vertex is the lowest point among all the points on the parabola. So therefore, we will get the minimum function value. Okay. So we are talking about function value. So function value is your y value, which is the y coordinate of the vertex. So again, this is how we remember it. If the if parabola is opening upward, we got minimum value. If similarly, if the parabola is opening downward, your vertex is the highest point. So therefore, we got what? A maximum function value, which is the y coordinate of the vertex. And this maximum and minimum, we will use it in application problem later on. But for now, what we want to do is we want to graph it. So once again, let me go back and then point out what is important. If the quadratic equations are in this format, okay, the quadratic function is in this form, ax squared plus bx plus c, then we will be able to find out the x-coordinate of the vertex. This is the only thing that you need to remember, the formula, because once you find out the x, you plug it in the x into the function to get your y. So now let's move on to the first example. So given to you the quadratic function x squared plus 2x minus 8. First up, we want to find out the vertex. So vertex, I have to find out what is my x-coordinate of the vertex. Right? The x-coordinate of the vertex That is basically what using the formula negative b over 2a. So in this case, my b is positive 2. 2 times my a is 1. So therefore, my vertex will be negative 1. And now we need to find out the y coordinate of the vertex. So the y coordinate, that is basically k. It is, if you know x, you can basically plug it in into what your function value f of negative 1. So that is basically negative 1 to the second power plus 2 times negative 1 minus 8, which will become 1 minus 2 minus 8. That will give me negative 9. So therefore, we got our vertex negative 1, negative 9. Remember, vertex is a point, so you need to give me in order pair. The axis of symmetry, which is the vertex is in the middle, right, exactly in the middle. So axis of symmetry will pass through the vertex, which is x is equal to negative 1, right? The axis of symmetry will pass through the x coordinate of the vertex, a vertical line. Now, we want to determine parabola is opening upward or downward. In this case, we will be saying, we know that parabola will be open upward. The reason is because, where do we check? My value a is equal to 1, which is that imply a is greater than 0. Right? That's the reason. Now, if the parabola is opening upward and the vertex is the very low, is the lowest point that you can get. So therefore, in this case, in this function, we will have a minimum function value. So part D, we will have minimum function value. Where does minimum function value occur? That will be the y coordinate of the vertex, which is negative 9, because that's the smallest y value that you can get, the function value you can get on the graph. And next step, we want to find out the x-intercept and the y-intercept. So for y-intercept, we know that let x be equal to 0. So that means I'm looking for f of 0, which is 0 squared minus, let me go back in and look at the formula again, plus 2 times 0 minus 8. So therefore, my answer is negative 8. My y-intercept is 0, negative 8. Don't forget, you need to write it in order pair. Then we want to find out the x-intercept. X-intercept, we let y be equal to 0. When y is equal to 0, that means f of x is equal to 0. So it will be 0 equal to x squared plus 2x minus 8. This gives us solving the equations, which is x minus 2, x plus 4, factoring out. So therefore, x minus 2 equal to 0, and then x plus 4 equal to 0. So x is equal to 2, and x is equal to negative 4. This tells us we have two x-intercept. One is 2, 0, and the other one is negative 4, 0. Now we're going to use the vertex and these x-intercept and y-intercept to graph it. Remember that my vertex is negative 1, negative 9, and here's my x-intercept and y-intercept. So my vertex is negative 1, negative 9, which is way down here. Let me use a different color. Okay. So x-intercept and y-intercepts, which is negative 1, 9, which is way down here. Then my x-intercept are 2, 0. Here's my x-intercept 2, 0. And my x-intercept, another one is negative 4, 0 right here. And my y-intercept is 0, -8, which is right here. And using the symmetrical idea, so from the vertex to the right 1 point, up 1 point, so it must be also to the left 1 point, up 1 point from the vertex, because they are symmetrical, right? So now I can use these points to graph my parabola. Uh-oh. So I can graph my parabola using this. So now this is much easier to graph a parabola now. Let's practice more. Let's take a look at on the next example. So let's find out the vertex, right? In this case, the x coordinate of the vertex, the formula is my h is equal to minus b over 2a. In this case, it will be negative. My b is -6. 2 times my a is -3. So again, this will give me -1 after we simplify. Then we will look for my y coordinate of the vertex, which is substituting the x value into the functions, so f of -1. And this will become -3 times -1 to the second power minus 6 times -1 minus 4. So therefore, this will give me -3 plus 6 minus 4, which is going to be -1. So now I know that my vertex will be x coordinate is -1, the y coordinate is also -1. The axis of symmetry is a vertical line that passes through the x coordinate of the vertex, so therefore it must be x is equal to -1. So these two examples so far, coincidentally, my axis of symmetry is the same. Okay, coincidentally. Now the next question is the parabola is going to be opening upward or downward. In this case, it will be open downward because my a is equal to -3. This is basically implied that a is less than what? 0. Okay, so it was opening downward. And if the parabola is opening downward, the vertex is the highest point that you're going to get. So therefore, in this case, we're going to have a maximum function value, which is the y coordinate of the vertex. It will be -1. So that means the parabola, the highest it goes is -1. Now, we want to find out the x-intercept and the y-intercept. So y-intercept, we let x be equal to 0. So that means I'm looking for f of 0, which is -3 times 0 squared minus 6 times 0 minus 4. Right? That's the formula. And so therefore, this gives me -4. So my y-intercept is 0, -4. Now, looking for the x-intercept, we let y be equal to 0. That means my f of x is going to be 0. So it will be 0 is equal to -3x squared minus 6x minus 4, which we want to solve for this. So first we're going to multiply everything by negative, so it becomes 3x squared plus 6x plus 4. Now the question is that factorable or not? This is not factorable, okay? So not factorable, so what we do is we use the quadratic formula to find out where my x is going to be. Minus b plus or minus square root of b squared minus 4 times a times c all over 2a. This tells me negative 6 plus or minus square root of 36 minus 16 times 3 is 48. So which is giving me negative 6 plus or minus square root of negative 12 over 6. And notice that if the square root under the square root is a radical, this is what? Complex number. And this basically tell what that mean is because of we are graphing on a real number axis, right? My x-axis is a real number, y-axis is a real number. So we have nowhere to graph the complex number. Another way of saying it in this case is no x-intercept. Okay? No x-intercept. So now I only have a few points now, right? So my vertex is -1 and -1. So let's keep on remember that. And then my y-intercept is 0, -4. So let's graph this. My vertex is -1, -1, which is going to be right here. My y-intercept is 0, -4, which is right here. And using the symmetrical idea, you notice that from the vertex, it's go to the right 1 unit and then go down 3 units. So therefore, I can also find out another point quickly by symmetrical idea. From the vertex, it moves to the left 1 unit and then go down 3 units, which is another point right there. So with this, I can quickly sketch my parabola. Don't forget the arrowheads at the end. Okay. Now we see both cases and then also the case that hasn't have the x-intercept. Let's move on and then looking at the application problem, which is relating to the maximum and the minimum function value. So in this case, it is given to you a quadratic function h of t is -16 t to the second power plus 128 t plus 32. And we want to find the height h of a stone thrown upwards from the height of 32 feet at a rate of 128 feet per second. How long would it take the stone to reach its maximum height? And what is the maximum height? So you have to read it carefully. First, it asks how long, right? How long would it take? And the second, what is the maximum? So first, it's asking for the time, and the second, it's asking for the actual height, right? What is the maximum height? So these type of problem is very important that you know what is your input value and what is your output value. So according to the function notations right here, okay, let's understand this first. The function notations is h of t. And this entire h of t is basically representing what? The height. And then the input is t by itself, right? That is the time. So when we look at this problem, this is how I have to look at it first. This will be the time is my input and the height is my output. So therefore, you can relate it back to your x coordinate and y coordinate idea once you got the order pair. So this is basically imply that here's my t and an h of t in order pair, right? The height. So every application problem like this, you have to look at your order pair first, so that way you know what you need to look for. So now, when they ask you what is the how long would it take to reach the maximum height, that is basically asking what is the time that it reach the maximum height. It is basically talking about the x coordinate of the vertex, interpretation wise. So to answer the first question, okay, to answer the first question, we the time, right? We want time reach max height. And I'm writing it out so for your notes purpose, the time to reach max height, that basically imply we are looking for the x coordinate of vertex, because in order pair we know that the time is what in the x coordinate part, which is the input part, and that helps me to clearly see the prompts and then look for the information. So in this case, my t will be equal to minus b over 2a, which is the formula for x coordinate of the vertex. So plug it in. That will be minus 128 over 2 times negative 16. Using the calculator, right? 128 divided by 2 times 16, which will give me positive 4. So now I know that at 4 seconds, after 4 seconds, this will reach what? The highest point. Now, part 2 is asking for what is the maximum height. So we want to know max height. So when it's asking for maximum height, that is basically we are looking at what? Y coordinate of the vertex. Okay? Maximum height is the y coordinate of the vertex. So in this case, we are looking at what? H of 4, because this tells me after 4 seconds it will reach the maximum height. So if I want the height, I need to plug it back into the functions. So that means that is negative 16, 4 to the second power, plus 128 times 4 plus 32. So which give me 16 times 16, right, is 200, negative 256 plus 128 times 4, that is 512 plus 32, and my final answer will be minus 256 and then plus 32. That gives me 288 feet. So now I know that maximum height will be 288. Not necessarily all the time I will be asking both of them on the test. So therefore, you really need to read carefully. Are they asking for the time, or are they asking for the actual height? Okay. So I would really recommend you to, look at your order pair first with the notations so that you can clearly see, which portion will be your using which formula. Okay. So let's try the next example. So this one, try yourself for a second. Right? Pause it and then try it. So it tells you a path of the rocket going upward is given by these functions right here. Okay. And now the question is, when will the rocket reach the maximum height? So when, that's talking about asking for what is the time that's going to reach the maximum height, and what will be the maximum height. So it's asking you when and what, two cases. So according to the order pair, we know that this will become what? The time is my input and then the height is my output. Because the notations, the function notations right here, it tells me my input is t and my output is what? H of t. That's how I interpret it, where the time and the height's gonna go. So to answer the part A, if I want to know what time when will give me the maximum height, that is basically asking for what is the x coordinate of the vertex. So again, when reach max height, that means, right? That means what is x coordinate of vertex. So to find out the x coordinate of vertex, my time t is equal to minus b over 2a, the formula. So that tells me minus my b in this case is 208 and my a is negative 16. So 208 divided by 2 times 16, that gives me positive 6.5. So the next question is, now I know that the rocket will reach maximum height after what? 6.5 seconds. Now the question is, what will be the maximum height? So what is my max height? That is basically talking about the y coordinate of vertex, okay, on a parabola. So that basically means what is the function value when it reached the maximum height at 6.5 seconds. So this will be equal to negative 16 times 6.5 to the second power plus 208 times 6.5. So using your calculator, 6.5 squared times with negative 16, that will give me 676 negative, and then plus 208 times 6.5, that'll give me 1352. And then when I subtract it together, that gives me my final answer 676 feet. So therefore maximum height is 676 feet. And this concludes our section.